Okay, students. So we have already finished the 10.1 and 10.2 theorem of your class 9, the geometry portion. So we'll discuss 10.3 and 10.4 today and the problems related to it. So first of all, see what the theorem says and what is the data given and what to prove. The perpendicular from the center of a circle to a chord bisect the chord. Okay. So first do the diagram. This is the center O. Suppose this is a chord. Okay. So what is data given? See, first S1 is a circle. Okay. O is the center. And AB is a chord. Suppose this is given up to this. Okay. This is the data given and this is the proof. To prove, what to prove? The perpendicular means here from this perpendicular, this is perpendicular. Suppose AX perpendicular AB. OX perpendicular AB. This is given. The perpendicular from the center of a circle. Center, this is center. From the center of a circle, the perpendicular is towards the chord AB is given, and I have drawn as per my figure. This is OX. So OX is perpendicular AB is given. So we have to prove. What to prove? To prove the second. What to prove? See, bisect the chord. This OX will bisect the AB. Okay. OX bisect AB. Okay. This means AX equal to BX. We have to prove AX equal to BX. So we can write OX bisects AB. Okay. The third construction. What to do in construction part? You have 4 parts. I am repeating. The data given. What to prove? It is already these 2 parts is given inside the question itself. And the construction you have to know to congruent these 2 parts. We have to congruent the triangle where these 2 will be a part of them. So join OA and OB. Okay. So join OA and OB. Okay. OA and OB will be same because it is the radius of the same circle S1. Okay. Now prove. How to prove? We have to make congruent these 2 triangle OAX and OBX, so that this part will be same as a part of Cbse, congruent part of congruent triangle. So we have to go for the congruency of these 2 triangles. Which one? This one and this one. These 2 triangles. Okay. This is given 90 degree from data. So between triangle, this one OAX and triangle OBX. See, what are the 3 situations or 3 conditions to make itself congruent? See, the first one is you have to only search for it. It is already present in the figure. You have to find out only. So this one is this OA equal to OB, radius of the same circle. First, OA equal to OB. You have to write down here radius of same circle. Okay. Second point is this is 90 given data from the see OX perpendicular AB means this angle is 90, this angle is 90. So the second point is OXA, measure of OXA equal to measure of OXB equal to 90 degree given. Okay, 90 degree given. Another, This is the common side for both the triangle. See, OX is a side of OAX triangle and OX is a triangle also OBX triangle. So third condition is OX equal to OX, common side. Okay, so you have got three conditions to make the congruency. What is the congruency said? Side, angle, side. Okay, so Sachs theorem. Okay, so triangle, which one? Which two? OAX is congruent to triangle OBX as congruency. Side, angle, side. Hence, I can write AX equal to BX Cbse. Okay, hence I can write OX bisect AB. Okay, finished. Okay, so nothing is difficult here. So, shall we go for the next theorem? The next theorem, see, we will proceed towards next theorem, 10.4. What is 10.4? Let me write the theorem first. 10.4. The line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Just opposite of this. The line, what is data given here is to prove here, and what is to prove here is data given here. Okay, just opposite. The line drawn through the center of a circle. Line drawn through the center of a circle. If this OX bisects AB, then prove that this it will be bisects a chord is perpendicular to chord. This will be perpendicular. Okay. So let's write down the question first. The line drawn through the center of a circle. The line drawn through center of a circle. Okay. To bisect a chord. Each perpendicular to the chord. Each perpendicular to the chord. Okay. So the same thing is here. The same data will be also here. Data given. S1 is a circle. O is the center. Okay. So this line OX bisects AB. That means AX equal to BX given. This is already given. Okay. You have to prove. What to prove? See what to prove. OX perpendicular AB. Okay. This OX must be perpendicular to AB. We have to prove this. Okay. Construction is also seen. Construction. Join OA and OB. The same thing. OA and OB. Okay. Now proof. How to prove? Proof. See how to prove. In this case also, we have to make these two triangles congruent. That's why we will proceed towards the proof, the final proof. Okay. So let's congruent first. Make them congruent first. So between triangle OAX and OBX. Okay, what are the three situations or three conditions to make them congruent? See, OA equal to OB, the same thing is here. OA equal to OB, radius of same circle. Okay, again AX equal to BX given, BX given, data given already in the theorem. Okay. So third one is, what is third one? OX equal to OX, common side. See, common side. OX is a common side for both the triangle. So what is the condition of congruence? Side, side, side. Hence, triangle OAX congruent triangle OBX. OBX SSS congruency. Side, side, side. So I can write corresponding angle same. Okay. So I can write here the corresponding angle same. So I can write what? This angle will be corresponding on this angle. So this will be same. This will be same to this. This will be same to this. This will be same to this. So I can write angle AXO will be equal to angle BXO or AXB or OXB or OXA. You can write also. Okay. But these two triangle is a straight line having supplementary to each other. See, these two triangles are same and the sum of them is 180. See, this is a straight line, straight angle. But measure of AXO plus measure of BXO is equal to 180 degree. Supplementary angle, because it is straight line, straight angle. Straight angle. Okay. So if each of them is equal and sum of them is 180, what will be each of them? 90. So AXO equal to BXO equal to 180 by 2 equal to 90 degree. So I found this angle 90 degree, hence it is, I can write now what? OX, hence OX perpendicular AB. Proved. Okay. The same thing is these two lines extra needed and the congruency is in that case SAS, but here it is SSS. Okay. Let's solve one problem regarding this type of theorem, these two theorem related application of these two theorem. Made some mathematical solution. So let me write the question first. If a circle intersect two concentric circles, if a line intersect two concentric circles, which with center O at with center O See, this is the concentric circle with center O. Okay. If a line intersect at ABCD, if a line intersect at ABCD, okay, concentric circle with center O at ABCD, prove that AB equal to CD. ABCD. Okay, A, B, C, D. Okay, prove that AB equal to CD. We have to prove that ABCD, center at O, with center O at A, B, C, D. Prove that AB equal to CD. We have to prove AB equal to CD. How to prove? Based on these two theorem, what we have discussed now, it can be solved. Okay, see how the solution is made. We have already told that suppose we constructed this one perpendicular. We know that 10.1, 10.2, the perpendicular will bisect AB. So construct OX perpendicular AB. Okay. Also OX perpendicular BC also. See. You have to construct here. Construct. Okay. Now prove. How to prove? See. See this one. OX perpendicular BC. So BX equal to CX. Theorem. Which? 10.3. 10.3. If perpendicular drawn from center, it will bisect the chord. That's why BX equal to CX for this S1 in circle S1. Okay, suppose this is S2. In circle S2, see OX perpendicular the chord AB. OX perpendicular the chord AB, the bigger chord. BC is a chord for S1 and AD is a chord of S2. So AB. So I can write, hence I can write also according to theorem 10.3, AX equal to DX. AX equal to DX. I can write. Okay. AX can be, and AX will be equal to DX, theorem 10.3. 10.3. Okay. Up to this. Could you follow clearly? Okay. Now see carefully what I am going, proceeding forward. See, if BX is equal to CX, can I subtract the same thing from here and here? Because if I subtract BX from AX, I will get AB. If I will subtract CX from DX, I will get CD. That's why I am subtracting. Okay. So AX minus BX is equal to DX minus BX. I can subtract. Okay. But here, in place of BX, can I write CX? CX, I can write CX. The same thing I am subtracting, same length. BX equal to CX. So I am subtracting AX minus BX. I am subtracting BX here. I am subtracting CX here. Because BX cannot be subtracted from DX, but CX can be subtracted from DX. And both these two are same in length. Okay. So, although BX equal to CX. See, BX equal to CX. So, I have subtracted the same length from each side. So, AX minus BX will be how much? AX minus BX. What is remaining? AB. DX minus CX. What is remaining? CD. This is proved. Finished. Okay. So, in our next video class, we will go towards the next two theorem, 10.6 and 10.7. Okay. So, join my channel and tell your friends to join the channel so that they will be benefited without any cost. Thank you.